Angles in quadrants, Algebra 2 trigonometry regions. So a bunch of notes on this one. First of all, we do a lot of our trigonometry actually on the XY graph called the Cartesian plane. Um, and first thing is you need to know what the quadrants are. And so there's some notes here about the quadrants. You might already know this, but the top left quadrant is quadrant 1, and the one to the left of that is quadrant 2. Below that's quadrant 3, and the bottom right is quadrant 4. So it starts in the top right and then goes counterclockwise. And what I'm showing you here is the angles they're between, because we use our x and y axes to represent angles. So we always start right here on the x-axis, the positive x-axis. That's our starting point, and so we would call that a 0-degree angle. And then the y-axis here would be a 90-degree angle. What I'm talking about is the angle between these. And you know that they're perpendicular, so there's 90 degrees there, so that should make sense for you, being that if this is 0 going this way, and we go counterclockwise, because that's what we do with our quadrants, we go around this way, that this would be 90 degrees because these are perpendicular. They form a 90-degree angle. From here to here would be half a circle, so that would be 180 degrees. I just want to erase that for now. And you could also think of it as, well, this is 90 and this is 90, so together that's a total of 180. So 90 you're very familiar with, 180 you're very familiar with. Down here we mark the bottom of our y-axis as 270. And that's not an angle we see as common as 90 and 180, but it's still very common. It's actually three 90s. 90 plus 90 plus 90 is 270. It's 3/4 of a circle is 270 degrees. And then the full circle, starting here and ending here, would be a full 360. So this mark we actually mark at 0 degrees and also 360 degrees. So we label the corners of our axes as 0, 90, 180, 270, and again 360. And that separates our quadrants. So quadrant 1 is between 0 and 90. Quadrant 2 is 90, 180. 3 is 180, 270, and 4 is 270, 360. And that's what this is all about. We know this theta symbol is our angle. So an angle between 90 and 180 is in quadrant 2. So if I want to draw an angle of 120 degrees, it's going to be in quadrant 2. The other thing I want to mention before I get into actually drawing the angles is that all the coordinates in quadrant 1 are xy, meaning x is positive and y is positive. Every point in here has a positive x and a positive y because it's right and up to get to those values. Every coordinate in quadrant 2 is negative xy. Like this point right here, this would be negative 3, 2. So that'd be the point, negative 3, comma 2. And every point in here is negative x, positive y. In quadrant 3 down here, it's negative, negative. Negative x, negative y, because it's left and down. So they're both negative. And then lastly, in quadrant 4, it's a positive x, but a negative y. So if I give you a coordinate, just like, all right, 2, negative 7, you should be able to tell me right away, all right, that's quadrant 4, because it's a positive x and a negative y. And that'll be helpful if you kind of remember that. All right, terminal and initial side of angles graphs, positive and negative angles, and coterminal angles. All this I'm going to use this one graph to represent. First of all, initial and terminal sides. As I mentioned earlier, we always start our graphs on the positive x-axis. So let me get a line in here. And just do your best to draw these pictures. I know you don't have the same tools that I have available on this program. But we start here. Let me make that thicker, actually, so you can really see it. So all of our angles start here. That's called the initial side. And what then happens is the angle opens up and ends somewhere. And so the angle is represented like this. It went like that. It started here, and this is called your initial side. Basically where it begins. And your initial side is always the same thing. It's always the positive x-axis. And then where the angle stops, we call the terminal side. It's where it terminates. It's where it ends. Okay? So it always starts here and ends there. Now, this would be an angle in quadrant 2. So this measurement is probably something like, 140 degrees. It's between 90 and 180. It looks to be about 140. If you had a protractor and measured it, you would see it's about 140, right? And so anything between 0 and 90 is going to be there. If I opened the angle to be, here, then it'd be between 180 and 270. Like if I wanted to draw an angle of, say, just throw, sorry, one sec. It's nice to have them overlap for when I'm doing it. Okay, so this would be, 45 degrees, 80 degrees, 90 degrees, 100, 110, 120, 140, 150, 160, 170, 180, 190, 200, 215, 260, 270. Oh, here's 270, then 280, 300, 315, 350, 360, so on. So an angle like this, and notice how I'm drawing the arc, that I'm starting here and then I'm drawing it here and I'm ending with like a little arrow because that's telling me that the angle is going this way. That would be an angle in this quadrant. That would maybe be 230 degrees, something like that. But then we also have positive and negative angles. See, positive angles are counterclockwise. And that's what we've been doing. Like this angle right here we drew. Let's call this a 140 degree angle. This 140 degree angle started here and went counterclockwise, the opposite way the clock hands travel. But negative angles also start at the initial side. They go clockwise. So positive angles are counterclockwise and negative angles are clockwise. So I can start here and then I can open the angle this way. And this would be a negative angle. Let me get the color there. So this right here, this was how I would draw a negative angle. And again, that arrow is important because it's telling me I'm opening this way. And so this is in quadrant 4, but it would be something like, say, negative 60 degrees. So like the 90, 180, 270, 360 we marked, that's for positive angles. It would go the other way for negative angles, like negative 90, negative 180, negative 270, negative 360. We tend to not remember those too much. Just remember that negative angles open down and clockwise, and that'll be helpful there. And then the third or last thing I want to talk about before I get to an example too is coterminal angles. Because what you're realizing is since angles can open both ways, like this angle of 140 I have drawn here, this 140, that's a positive 140, but couldn't it also be a negative angle like this? And so this positive 140 and this negative angle terminate at the same place. That's what makes them coterminal, is they end at the same spot. End at same spot. And there's a relationship there because together they form a circle of 360. So if I want to find a coterminal, I could just add or subtract 360 to what I have. So like this 140 I have here, if I have 140, well, if I were to do 140 minus 360, whether in my head or in my calculator, 140 minus 360, that's going to get me the negative coterminal angle. So that's negative 220. Negative 220. And so positive 140 and negative 220 end in the same location. And together, they form a full circle of 360. All right, a couple of quick examples because I don't want the video to go too long, but they're pretty short. For angle theta 140 degrees, state the quadrant that it's in. So let's see, that's a quadrant 2. Draw an angle sketch. So what I want to do here is just draw a sketch, and 140 is in quadrant 2. I don't care how perfect they are here. Just give me a line in there, and then the arc drawing to it. That's what I'm looking for a quadrant 2 angle. And then state two coterminal angles. Well, I'm basically just going to do 140 minus 360 and 140 plus 360. And let's see what those give us. So 140 minus 360. Oh, we already have that in there. Negative 220. And 140 plus 360, that would be 500. Now 500, isn't that way more than 360? Well, what's happening is basically an angle of 500 would be starting here, going all the way around a full 360, and then another additional 140. And so you can have angles greater than 360, but they're just basically angles very similar to less than 360. So to find coterminal, just minus 360, add 360. That's pretty simple right there. One other quick question I want to do. I'm going to skip the 3 and do 4 for you. Actually, let's skip to 5. So I'm giving you a point here. State the quadrants. Again, sorry, so that's negative and positive. I'm talking about quadrant 2 again. Draw a sketch. The sketch would look like this. That's a little sloppy. Let me do that again for you. And draw the arc. And then I want you to create a right triangle and find the hypotenuse. So what I want you to do when you're creating a right triangle is your terminal side is the hypotenuse. So this line here, this sloppy line that I drew, that's going to be my hypotenuse of a right triangle. And the way we always create the right triangle is we draw a vertical line down or up to the x-axis. We never draw it to the y-axis. We always draw it to the x-axis. And then label what you have. This is my x and this is my y. So here's my x value of -3, my y value of rad 7. Now I could just do a little Pythagorean theorem to find that hypotenuse length. -3 squared plus rad 7 squared, and -3 squared is 9. Rad 7 squared is 7. 9 plus 7 equals 16. So this equals, h squared. And so my hypotenuse is going to be 4. That's always a positive number. Your hypotenuse is always positive. Okay, sorry I'm rushing a little bit towards the end. The video is running late. I apologize for that. I always like to keep it around 10 minutes, but there's a lot of important good notes here in the beginning that hopefully sunk in, and we'll obviously discuss all of this in more detail in class.